Hey, welcome to the week 4 lecture on articulations. Articulations is another term that means joints. So, in this part of the lecture, we will be looking at where bones in our skeleton are joining together in different ways. Sometimes to allow for a movement, sometimes more for stability and prevention of movement. So we'll start off by looking at how we can classify different articulations, different joints in our skeletal system. We'll be looking at both functional and structural classifications. A functional classification is going to be looking at how much movement is possible at a joint. And then structural classifications, we're going to be looking at the actual structures involved, what tissues are forming those joints. The majority of this presentation will be focused on the structural classifications. And these are the three major types, the fibrous joints, cartilaginous joints, and the synovial joints. As you can see under here, under synovial joints, we have a lot of different topics to work through, just because synovial joints are the most common joints in the skeleton. Okay, so let's introduce articulations a little more. So as I said, articulations or joints are the location where bones come together. They contribute to both the movement function of our skeleton, so allowing us to complete voluntary movements of our limbs, of our trunk, of our head, as well as these underlying these movements. Joints are also really important for the support functions of the skeleton that we discussed last week. So you think about, when we're looking at the skull, when we're looking at the thoracic cage, there we need multiple bones to come together to have a supportive role and a protective role. And we'll talk about how different joint structures and materials define what movement and support we're going to see at a particular joint. So as I've already hinted at, many joints allow for movement between the bones. And probably before you took this course, that may be how you thought a joint would work. Like you can have a shoulder joint or your hip joint, somewhere where there's movement going on. So yeah, many of the joints that we're going to look at today are of this form. This is where we have those articulating surfaces of the adjacent bones moving smoothly against each other. But as well as these more conventional joints, some of our articulations are very different. And you've already met these in the lab when we have looked at the skull. So we've seen in the skull, bones that are joined together by connective tissue. We also have seen joints that are held together by cartilage, particularly when we were looking at the thoracic cage in our last lab meeting. So these are joints that are designed for stability and provide for either no movement or a very small amount. Now, it's important to know that there are more joints in the body than bones. You can see that this has to be the case if you just cast your mind back to our most recent lab meeting where we were looking at the vertebral column and the thoracic cage and how they interact with each other. So here is that diagram I was showing you of how a single rib is making these three different points of contact with the vertebral column. So we had this one joint formed here against the transverse process of one vertebrae. And then we had two further points of quite close contact between the rib and the vertebral column here on the body of the two adjacent vertebrae. These are joining with these 2 points on the head of the rib to form two other actually very small synovial joints. Now each rib also is coming around here. This will be heading towards the front of the rib cage. So on the anterior surface where it is joining with the costal cartilage, which also then joins with the sternum at the very front. So if we include this articulation with the costal cartilage, then just every single rib is going to be forming 4 joints with the rest of the skeleton. So this really helps you see how there are many more joints in the body than there are individual bones. So as I mentioned in the overview at the beginning, joints can be classified by either function or by structure. So the functional classification is based on the amount of movement that is occurring at the particular joint. The first class are called synarthroses. These are immovable joints. These are most common in the axial skeleton, and you've already met many of them when we've been looking at the skull. Now, there's an in-between in this functional classification. These are the amphiarthroses. These are joints that are slightly movable. They're also common in the axial skeleton, so the part of our skeleton that makes up our middle axis. The third and final class in the functional classification are the diarthroses. Diarthroses are freely movable joints, and these are particularly common in the appendicular skeleton. So this is where our limbs, both upper, our arms, and lower limb, our legs, are joining onto our axial skeleton. So these diarthroses, freely movable joints, are very common in this portion of our skeleton. And these freely movable joints are all synovial joints. Now, the second classification method for joints involves looking at the structure of the joints. It's based on what material is binding the bones together at these joints, and also whether there is a joint cavity or not. So the presence or absence of a joint cavity is part of the structural classification. So our structural classification includes fibrous joints, where we have fibrous connective tissue holding the bones together, cartilaginous joints, where we have cartilage holding the joint together, and synovial joints. So let's look at each of these in more detail. So we'll start with fibrous joints. So at a fibrous joint, adjacent bones are directly connected to each other by fibrous connective tissue. This is going to be connective tissue that has usually a lot of collagen fibers in the extracellular matrix there. The bones in a fibrous joint do not have a joint cavity between them. And the gap between the bones making the fibrous joint can sometimes be quite narrow. Sometimes it can be wider, and those fibers are a little bit longer. And it's these differences that lead to there being three types of fibrous joint. So let's look at those three types in turn. So the first type you've already met in the lab. These are the sutures. Sutures are a fibrous joint between bones that are tightly bound by a minimal amount of fibrous tissue. And the only example of these in the body occur between the bones of the skull. So we've already met these when we've looked at the coronal, squamous sutures in the skull. Now, the purpose of not having, a continuous bone here forming the skull, forming the cranium, is so that bone growth can occur during development so that the skull can expand with the brain. What does happen, though, once we've finished the major growth period after puberty, the fibrous tissue here in the joint between the bones in the suture can start to ossify. So that means it becomes more bone-like. And when this happens, we say that these sutures have become synostoses, which means closed sutures. Okay, another form of fibrous joint are the syndesmoses. I'm just going to hide myself away so that you can see the slides better. Okay, so in syndesmoses, we have bones in that joint connected exclusively by ligaments. So as you know, ligaments are also a dense fibrous tissue. The bands of fibrous tissue in a syndesmosis is longer than those that we saw at the sutures in the skull. And the example given in this diagram here is this ligament that is running between the fibula and the tibia, just above where the ankle joint is forming here. So here we have quite a short set of fibers holding these two bones together. And this is important because it helps increase the improve the distribution of forces between these two bones in our lower leg. This joint here is immovable, so it's also a synarthrosis. Even though we're looking at this from the structural classification, we can then look within this classification back to a more functional viewpoint. Because these fibers are pretty short, there's not a lot of movement there. Okay, so if we have longer fibers, which we have in this case, here we're now looking at the forearm here, so between the elbow and the wrist. And we can see the radius and the ulna here. Now, the syndesmosis we are looking at is this structure here, which is called the interosseous membrane. So inter between, osseous bone, so a between bone membrane. So this is a connective tissue structure that unites these two parallel bones, pretty much, through their whole length. And it prevents their separation, so that when forces are acting on our forearm, these are going to be very hard to move apart. You'll notice that it does not prevent all movement between the bones because these are quite long fibers, So this kind of joint is considered an amphiarthrosis. That means slightly mobile. And we'll see when we look at the muscular system in the coming weeks that these two bones here actually turn over each other. So when we're pronating our arms, that's when we're turning our hand over. These two bones are running past each other, folding over, and then opening back out again. But we don't want them to open apart too far, and that's what the interosseous membrane helps with. Yep, so these syndesmoses can either be immobile or slightly mobile, but they have this fibrous connection between the two bones. Now, our third kind of fibrous joint are the gomphoses. And again, I'm just going to minimize the picture here so you can see all of the labels. A gomphosis is a joint that anchors the root of a tooth into the bony socket within the maxillary bone or the mandible, depending on whether it's in the upper jaw or the lower jaw. This is how our teeth are held into our jawbone. So this fibrous joint here consists of very small connecting ligaments, the periodontal ligaments. These are short bands of dense connective tissue. Now, obviously, we want to keep the tooth in its socket very immobile. So this is a synarthrosis because this joint needs to be immobile.